we want to test our variable age. Wait a minute, what is the specific number? Test the value. We want to compare to the specific number, that is 30, right? And then I type the number 30. Click OK. Okay, now let's read. Next step, run analysis, finish. Check significant or not. Here. So, see, it's here. It says two-sided, two-tail. Significant value. Now, tell me, this is also called p-value. Okay? In SPSS, input like this, but this is p-value. Now, please tell me, this number is smaller than 0.05 or greater than 0.05. Smaller, right? So, report p-value. P-value is negative 3.23. 3.23. And the p-value is smaller than 0.05. Finish. Wait a minute. Conclusion with means. So what is conclusion? What is conclusion? If you recall our hypothesis, null hypothesis is the mean of the variable age is equal to 30. Alternative hypothesis, the mean of the variable age is not equal to 30. And now its significance. It means it's here. It's here, right? It's here. So we reject our null hypothesis. We accept our alternative hypothesis. So what is alternative hypothesis? The alternative hypothesis is the mean of the variable age is not equal to 30. Wait a minute. You say not equal to 30, but you do not tell me the number is greater than 30 or smaller than 30. Okay, so how to tell that? What is the mean score? Mean score. What is the mean score? 27.9. Okay, now I know how to address the conclusion. So the conclusion is the mean of the variable age, put the quote, mean score 27.90, okay, is what? Is significantly smaller than the number 30. Alright, so let me say that again. The mean of the variable age, quote, I put the mean score, mean, okay, equal to 27.9, is significantly smaller than the number 30. See, in my conclusion, I tell you the number. I tell you the number is greater or smaller than 30. Okay? So that is what I want you to see. Don't just tell me the conclusion. You need to tell me the details, okay, with the mean. So if you say the result is the mean of the variable age, quote, mean score 22.7, quote, is significantly smaller than the number 30. Now I know what happened to that. You just accidentally hit the bar. You have the right answer, but your mean number is wrong. So you must do something wrong to get the wrong number, right? So I need to see your mean scores. Otherwise, I don't know if you do that in the right way or do that in the wrong way. Is that okay? Of course, when you read the paper, they also provide those information. there a difference between males and females? Sorry, on the variable, okay, WS1, what is the null hypothesis? Wait a minute, let's check. We have males, we have females. They are from the same group or they are from different groups. They are from different groups, right? So we have to select a dependent t-test, right? So what is the null hypothesis? The null hypothesis is there is no difference between males and females on the variable WS1. So what is the alternative hypothesis? Okay. There is a difference, okay, between males and females on the variable WS1. Okay? Now, this one, not that one. Run analysis. Analyze. Compare means. Independent sample t-test, independent t-test. Grouping variable. Gender. Wait a minute, professor, what is this? We have the coding number 1 and 2. What does this mean? Check. Okay, male is 1, female is 2. You need to check that. In the test, it's very possible that I may give you 3 is male, 5 is female. It doesn't matter because the number just represents the group. Okay. But if you put the wrong number, let's see what's gonna happen. Okay. And then we want to compare what mean score on variable WS1. We enter as the variable. Here we say we have 1 and 0. So we have condition 0. We don't have that. So let's test that. You'll get a warning sign. See? The independent samples table is not produced. Why? Because you put the wrong number. See? Hello? We don't have condition 0. You have to enter condition 1 and 2. Okay, that is our coding number. We have to enter 1 and 2. 1 is male, 2 is female. Okay, stop. Run analysis, finish. Check. Test of equality of variances. Levin's test for equality of variances. Now, tell me significant or not. Significant. If that is significant, see? Read which line? Read which row? Second row. So, we have to get the result from here, not here. So, if you get the result here, let's assume that you get the result here. What is the t-value? Negative 2 point what? 2.19, sorry. Pay attention on that, round to the last 2 decimals. The answer is negative 2.20, right? That is the wrong number. You need to read the second row. The correct number is negative 2.1 what? 19. Not in Beijing, okay? Okay, 2.19, not 2.20. So if we put 2.20, I know you totally read the wrong row. You totally read the wrong numbers. Okay? So, check test of equality of variances. Significance. We read the second row of the results. Then report t-value and p-value. So our t-value is negative 2.19. P-value, just tell me greater than 0.05 or smaller or equal to 0.05. Smaller. So when you see smaller, what does this mean? They are different, right? Yeah, it's significant, and they are different. They are different. Let's go back to our hypothesis. What is the null hypothesis? The null hypothesis is there is a difference. There is no difference between males and females on the variable WS1. And what is the alternative hypothesis? There is a difference between males and females on the variable WS1. Now the result is significant, so we reject. Okay, it's here. Okay. It's here. We are here now, right? We are here. So we reject, okay, our null hypothesis. We accept our alternative hypothesis. So what is our alternative hypothesis? There is a difference between males and females on the variable WS1. Wait a minute. If there is a difference between males and females, which one has greater number? Which one has smaller number? You have to tell me. Now let's check. See, this is male, condition 1. This is female, condition 2. So now, how to adjust this? Okay. The mean for the male group, okay, the mean for the male group quotes, mean equal to 2.88 is what? Significantly smaller than the mean for female group quotes, 3.15. Wait a minute, on what? On the variable WS1. You need to tell me on which variable, right? You need to tell me what variable you are testing. Okay, or you could reverse that. You could say mean score for female quote 3.15 is significantly greater than the mean for male quote 2.88. Okay, so you could do that either way. It's fine, but you need to clearly tell me if you see any significance. If you see any significant results, you need to tell me. Okay, so if you see any if you see any significant results, you need to clearly tell me the mean scores. Okay, so don't forget we check the test for equality of variances, and if this one is significant, you need to read the second row. If this one is not significant, you need to read the first row. Okay, that is our independent test. And second one, question 2b, is there a difference between males and females on another variable that is called variable WM4? Again, the null hypothesis is there is no difference between males and females on the variable WM4. Alternative hypothesis, there is a difference between males and females on the variable WM4. Okay, so let's check WM4. WM4. First, check the test, Lorentz test for equality of variances. So now, please tell me the significance. This one is p-value. Excuse me. P-value is greater than 0.05 or smaller than 0.05. Greater. So that is not significant, right? So we, sorry, this part, sorry. That is not significant, right? So we read the first row of the results. Okay, so if you see the first row, that is 1.03. The second row, 1.02. So apparently, if you read the wrong number, if you read the wrong row, you will get the wrong number. So the correct number is 1.03. P-value, okay, smaller, greater than 0.05. So that is not significant. If that is not significant, we accept our null hypothesis. What is null hypothesis? There is no difference between males and females on the variable WM4, right? Wait a minute, professor said we have to report the mean score. Let's do this again. There is no difference between males, quote, mean, okay, 4.10, okay, and females, quote, mean, 4.01, okay, on the variable what? On the variable WM4, okay? So this is the way we report not significant findings. That's one. So we assume that we measure job satisfaction in January and in July from a sample. Is there a difference between the two time points? Let's check the variable. See, variable January and variable July. Where is that? See, they are from the same people, right? For number one, we have number January and July. Number two, the same. So as I said, if you see two mean score, two numbers, and they are from the same person, we have to select. Select what? We have to select pair t-tests. Okay, so what is the hypothesis? Hypothesis is there is no difference between the variable January and the variable July on the job satisfaction. Okay, and alternative hypothesis, there is a difference between January and July on job satisfaction. Okay, now let's run the test. Pair t-test. Again, compare means. So you can see, you can find the three t-tests in this option, compare means. Pair t-test. We have January. We have July. Okay. Check, run analysis. P-value, where is our p-value? It's here. So please tell me this one is smaller than 0.05 or greater than 0.05. Smaller, okay. But that is not 0, but it's very close to 0. See, it's very small, but that is not 0. So you cannot say, well, the p-value is 0. You have to say the p-value is smaller than 0.05 or 0.01 is fine. Okay? Now we know it's the result is significant. Okay, the result is significant. Fine. So the null hypothesis is there is no difference between the variable January and July on job satisfaction. And the alternative hypothesis is there is a difference between January and July on job satisfaction. And the results show that it's significant. So which means we need to tell our people which one is greater, which one is smaller. Again, mean score. where is the t-value? T-value is negative 8.15. And p-value is smaller than 0.05. Here is the mean score. So we know the mean of the variable January cost mean score 2.98 is significantly smaller than the variable of July cost mean is 3.42 on job satisfaction. Okay. Or you could do that in the opposite way. You could say the variable of the July cost mean is 3.42 is significantly greater than the variable of January cost mean is 2.98. So you need either significant or not significant. You have to tell me the mean scores you have from the output from the results. Would that be okay? So I have to double check that. It's very possible that you they are significant. It's very possible that no, just randomly select some people. Not significant. Let's assume that this one is significant, okay? And it's very possible that this one is significant. And then you have the two mean scores. But your two mean scores, they are different from the correct answer. So even though I know you said the result is significant, your mean scores are still wrong numbers. That is the reason I want you to report. I want you to report the mean scores, so I can double check that. Of course, when you read those journal articles, it's necessary to report mean score and standard deviation. But it's the class, so I won't ask you to report lots of information in the class. Just report the mean score. That is enough for me. Okay. So far, any questions? No? Okay, so now is a question.